Okay, the crash test dummy problem. Well, concept question. A crash test dummy is placed in a car and put through two tests. One, where the car is moving 30 miles per hour when it crashes into a barrier and the airbag deploys. And two, where the car is moving 30 miles an hour when it crashes into a barrier and the airbag does not deploy. The car is brought to a halt by the crash in both tests. Okay, so one airbag, 30 miles an hour to 0. And in situation 2, no airbag, and all this is the same. Okay. So A, compare the impulse delivered to the dummy in the two tests. Briefly explain your conclusion in your written work. Okay, so impulse is the same, right? Impulse is equal to the change in momentum of the crash test dummy, okay? And because the crash test dummy is going 30 miles per hour and goes to 0 in both cases, right? The final momentum of the crash test dummy will be 0. And the initial momentum of the crash test dummy is just whatever its mass is times velocity. So whatever 30 miles per hour is converted into meters per second, okay, to have standard units. This is same for both cases. So impulse is the same. For B, say that the airbag doubles the time it takes for the dummy to come to rest during any crash. How fast would the car have to be going before a crash with the airbag so that the dummy would experience the same acceleration as it does in test 2? Okay, so this one you have to put on your thinking cap just a little bit for, and look at the definition of impulse, which relates to the average net force acting on an object. Okay, that's going to be related to the acceleration, right, from Newton's second law. So really what we're looking for is force average, which is going to be proportional to the acceleration, and that's going to be equal to change in momentum over change in time. Okay. Now I've already established that this is the same as long as you're going at the same speed down to 0. But here, right, it's not going to be the same because we're purposefully saying, okay, well, how fast would you have to be going to get this same acceleration and thus average force and thus, like how much damage is going to be done to this crash test dummy. Okay, so say this is written out, the situation in test 2, okay, just symbolically. And then in the new situation, we'll call it situation 3. Well, we want all the same stuff, right? We want the same acceleration, so I'm going to call it all the same thing. And we're saying that the airbag doubles the time. We have the airbag here, so we put in 2 delta t. And the only thing for us to figure out is, okay, by what factor does the change in momentum have to go up so that these two things match? Well, pretty obviously, if you just look at the fraction there, it just has to be twice as big. The mass of the dummy doesn't change, so twice the change in momentum means twice the initial speed, that 30 miles per hour, okay? So 2 times 30 miles per hour 60 miles per hour. Okay. So if the airbag doubles the time it takes for you to come to a halt, well then a 30 mile per hour crash with no airbag is equivalent to its effect on you in the crash test dummy as a 60 mile per hour crash with the airbag. Pretty nice. And we're done.